Yes, welcome back to Power Systems 2 online series. And yesterday in previous class we solved one problem regarding to performance of the long transmission lines. That is ABCD constants we found in two methods we found. So and I told you, so we can follow any one of the method which is easiest for you. Generally, we used to follow the series method. Generally, we follow the series method. Okay, and today also we solve one more problem. And if possible, so we'll see one concept also. So, which is that in the sense, suppose for example, one impedance is connected in series with the receiving end, then how ABCD constants are changed. That is one concept. And another one is, if suppose the impedance is connected in series with the transmission line at sending end, then how ABCD constants are changed. If suppose this is case 2, and case 3 is, suppose the impedance is connected in series with the transmission line at both sending end and receiving end, then how ABCD constants are changed. Okay, we will see all these things today if the time permits. Okay, as first you should write on the problem. a three phase a three phase overhead transmission line. A three phase overhead transmission line has a total series impedance total series impedance per phase of 200 at an angle of 80 degrees ohms, and a total shunt admittance of 0.0013 at an angle of 90 degrees Siemens per phase. Full stop. The line delivers line delivers a load of 80 megawatts at 0.8 power factor lagging. At 0.8 power factor lagging and 220 kilovolts 220 kilovolts between the line. Kilovolts between the lines. Determine the sending end voltage and current by using rigorous method. Okay, now let us solve this problem. So first you see that he has given the impedance and admittance per phase. That means the total impedance, total admittance is given. So hence it is not required to know about the length of the transmission line. Yes, that is the point 1. And second point is, and he asked to determine Vs and Is by using rigorous method. So rigorous method in the sense, in which transmission system we use the rigorous method? Long transmission. Therefore the problem is under long transmission line. So this is how you can differentiate the problem under long transmission line and short transmission line and medium transmission line. Okay? Yes. First let us write the given data. Yes, how much receiving end voltage he has given? VR is equal to, yes, what is VR? 220 kilovolts. That means 220 divided by root 3. This is phase voltage. So which is this is approximately 127,000 volts. Approximate value let us take. Next, receiving end current IR is equal to what? How we can find? The power delivered divided by 3 into V phase into cos pi. That is, power delivered is 80 into 10 power 6 divided by 3 into V phase in the sense 220,000 divided by root 3 cos pi 0.8. Then how much you will get? 262.43 amperes. 262.43 amperes. Yes. Then what is power factor angle? We know pi is equal to cos inverse of 0.8, that is 36.87 approximately. Okay. Then how you represent IR? That is, IR can be represented as IR is equal to 262.43 at an angle of minus 36.87. Okay. Then he has given the value of Z and Y also. What is Z? Series impedance is 200 at an angle of 80. Okay. And what is shunt admittance? And Y is equal to shunt admittance, Y is equal to 0.0013 at an angle of 90 degrees. Okay. Now let us find the value of YZ, Y square Z square and Y cube Z cube. Now what is yz? Multiply these two. That is 200 into 0.013 at an angle of 80 plus 90. So hence how much this value? 0.26 at an angle of 170. 17, and we can expand this value, that is complex form we can write. Yes, if we write the complex value, yz is equal to minus 0.25605 plus j 0.04515. Okay, so let me write clearly. This is minus 0.25605 plus j 0.04515. This is the value of yz. Next, our duty is to find y square z square. That is y square z square. Yes, this is 0.26 square at an angle of 170 into 2. So hence this is 0.676 at an angle of 340. Yes, this will be 0.06352 minus j 0.02312. Okay, now we find what is y cube z cube. That is 0.26 cube at an angle of 170 into 3. So this is 0.1017576 at an angle of 510. At an angle of 510. Yes, this is the data we have. Now let us move to the series method. That is, what is the value of a? That is 1 plus yz by 2 plus y square z square by 24 plus y cube z cube by 720 plus so on. So we find this value. This is equal to 1 plus yz by 2. This is minus 0.25605 plus j 0.04515 by 2. Yes, next plus 0. Y square z square 0.06352 minus j 0.02312 divided by 24. plus minus 0.01522 plus j 0.008788 divided by 720 divided by 7. So just I substituted all values. Then let me simplify this. A is equal to D is equal to, yes, if you separate real and imaginary, this value will be 0.8746 plus j 0.02162, and this can be 0.8749 at an angle of 1.42 degrees. Yes, similarly, now let us find B value. B is equal to Z into 1 plus yz by 6 plus y square z square by 120 plus y cube z cube by 5040. Okay. And if you substitute all values, and you may get the value of B as B is equal to 191.57 at an angle of 80.43, and hence what is C? C is equal to y into 1 plus yz by 6 plus y square z square by 120 plus y cube z cube by 5040. Then what is C? Value of C is around 0.001245 at an angle of 90.43. Yes, 90.43. Okay, now we find the sending end voltage and sending end current. Yes, where Vs is equal to A into VR plus B into IR. You substitute all values as it is, and you check that the answer is approximately 1,52,174 at an angle of 14.23. Okay, this is phase voltage, and line voltage is √3 into this value. This is 263 574 volts approximately. Okay. Okay, now let us we find the sending end current. IS is equal to IS is equal to C into VR plus D into IR. We substitute all complex values as it is. This value is 187.5 at an angle of 7.65 degrees. You should check whether the answer is right or wrong. Or you can also 185. 185.8257 plus J 24 to 4.95. This is how we can solve the problem. Yes, now this is very interesting concept. It's very interesting concept. What is this? What is that in the sense? When the series impedance is connected in the transmission line. That's right. It keeps adding. The series impedance is connected in the transmission line. Series impedance is connected in the transmission line. Series impedance is connected in the transmission line. So here we will see the three cases. Yes, the first case is the impedance is connected at receiving end. Second case is the series impedance is connected at the sending end. And third case is in both ends. It is connected at the both ends. So case A. The transmission line with series impedance at receiving end. Transmission line with the series impedance at receiving end. Yes, here let us we assume this is sending end voltage. Yes, let us we assume this is transmission line. Sending end voltage, sending end current. Now the load is here. Yes, for this load, one series impedance is connected. Generally, series impedance in the transmission line indicates it is the combination of resistance and inductance. It is the combination of resistance and inductance. Yes, let it be this is ZSC. And here voltage at receiving end is VR. The current here is IR. Yes, whatever the value of VR we have taken in the earlier case, now it is changed because some other impedance is connected in series with the load. But there is no change in the receiving end current. There is no change in receiving end current. So let us we assume this is the value of VR dash. VR dash. VR dash. Yes, now the line auxiliary constants, that is ABCD constants, and as we determined in previous case, with the insertion of the series impedance, those are changed at the receiving end. Yes, normally an impedance is supposed to consist of resistance and inductance, and the current flowing through it is the same as the receiving end IR, as these two are connected in series. So now let us we assume the transmission constant, that is auxiliary constants of the transmission line are A, B, C, D. A, B, C and D. And ZSE is ZSE. ZSE is the series impedance. And VR is the phase voltage at the load end. And IR is as usual. Therefore, here VR, we should not substitute VR. Instead of VR, we need to substitute VR dash. Yes, what is VR dash? VR dash is equal to VR plus IR into ZSE. VR dash is equal to VR plus IR dash to ZSE. So now we know the equations for Vs and Is in terms of ABCD. That is, Vs is equal to A into VR dash plus B into IR. Yes, here what is VR dash? A into VR plus IR into ZSE plus B into IR. Now we separate VR terms and IR terms. This is A into VR plus A into ZSE plus B into IR. These are the new values of ABCD constants of long transmission line when the impedance is connected in series with the transmission line at receiving end. Okay? This is A as usual, and here entire this we used to take it as B. Yes, I will write later. Similarly, what is IS? IS is equal to C into VR plus D into IR. This is C into VR dash, VR plus IR into Z plus IR, D into IR. So this can be rewritten as CVR plus CZ plus D into IR. Thus, from VS equation and IS equations, what is an equation for a new, that is modified ABCD constants? Yes, let me assume modified ABCD constants are A naught, B naught, C naught, D naught. Then what is A naught? A naught is equal to A1. What is B naught? Yes, it is changed. That is B plus A into ZSC. What is C naught? is equal to C only. What is D naught? D naught C into ZSE plus D. Plus D. Yes. Yes, is it over? Now let us go to the second case. What is second case? The transmission line with series impedance at sending end. Transmission line with series impedance at sending end. Yes, let it be, this is sending end. Sending end voltage Vs, Is, this is Z, Se. Now you have the transmission line. This is load, Vr. It is IR. Okay, and here as ZSE is inserted at sending end, the voltage at sending end is changed. Vs dash like that you need to take. Yes, in this case the current passing through the series impedance ZSE is the same as sending end current Is, because sending end voltage source and ZSE are connected in series, therefore the current is same. Hence the current is same. And if A, B, C and D are the auxiliary constants of the transmission line, Vr and Ir are the phase voltages at the load and supply ends respectively. Ir is the load current and Vs dash is the phase voltage at the starting end of the transmission line. So hence here we can write Vs dash is equal to A into Vr A into Vr plus B into I. Next, similarly, what is Is? C into Vr plus D into IR. And from the circuit diagram we can write equation for Vs as Vs is equal to Vs dash plus Is into Zs. Is into Zs. Yes, now let us substitute the values of Vs dash and Is here. Yes, Vs dash and Is here. Yes, where Vs dash is equal to A into Vr plus B into IR. And what is Is? Yes, then what is Is? C into Vr plus D into IR into ZSE. Yes, now you simplify this and take the common of Vr and IR. then Vs is equal to Vs is equal to AVR if we come at last final, we get this equation as Vs is equal to A plus C into ZSC to VR plus B plus D into ZSC IR. There is no change in C and D. That is, here A naught, new values are A naught is equal to A plus CZSC and B naught is equal to B plus D into ZSC B plus ZSC ZSC, and there is no change in C. C is as it is. C naught is equal to C and D naught is equal to D. Yes, D naught is equal to D. Yes, do you got these values? Yes. Now case 3. Case 3 is the transmission line with the series impedances at both ends, that is at sending end as well as receiving end. Sending end as well as receiving end. Yes, here just you assume that at sending end the impedance is Z S E capital S, like that you assume. At receiving end Z S E capital R, like that you assume. And you obtain the values of A naught, B naught, C naught and D naught. Just do this, and if you do this you may get the values of A naught as. If you have any doubts, just you ask me. Does A naught is equal to A plus Z into C, and B naught is equal to B plus A into ZSC R plus ZSC S plus C into ZSC R into ZSC S, and C naught you will get C as it is, and D naught is equal to D plus C into ZSC R. ZSC R. Okay. Yes, practice this, and still we have the time. We can get this derivation. After this derivation, so we'll see one more concept, that is transmission line with the transformers at both ends. If we insert the transformer, because the transmission line always with the transformers only. At sending end, after generation we are placing the transformer. At receiving end also we are placing the transformer to step down the voltage. Then how we need to take the values of ABCD? Yes, this we will see in the next class. Yes, thank you for watching this. Stay home, stay safe. Yes, practice more. Yes, don't forget to take precautions while you are going to the outside. Thank you once again.